Physics, the fundamental science that explains the mysteries of our universe. From the smallest particles to the largest galaxies, physics is all about understanding how things move, interact, and exist. But what exactly is physics, and why is it so important? Physics is the branch of science that studies matter, energy, and the fundamental forces that govern the universe. It helps us answer questions like, why do objects fall? How does light travel? And what keeps planets in orbit? At its core, physics is about observing natural phenomena and using math to describe them. The story of physics began thousands of years ago. Ancient philosophers like Aristotle tried to explain motion and the natural world, but it wasn't until Galileo Galilei, the father of modern physics, that experiments were used to test ideas. Then came Sir Isaac Newton, who introduced the laws of motion and gravity, laying the groundwork for classical physics. In the 20th century, physics took a giant leap with Albert Einstein's theory of relativity, which explained the nature of space and time. Around the same time, quantum mechanics emerged, unlocking the secrets of particles at the smallest scales. Physics isn't just for scientists. It's the foundation of many technologies we use daily. Without physics, there would be no airplanes, smartphones, or clean energy solutions. Studying physics reveals how the world works and develops critical problem-solving skills. Physics is a vast field with several branches. Classical mechanics deals with the motion of objects, forces, and energy. Thermodynamics explores heat, work, and energy transformations. Electromagnetism studies electric and magnetic fields, the basis of electronics. Quantum physics focuses on particles at atomic and subatomic levels. Astrophysics explains the behavior of celestial objects and the universe. In this journey into physics, we'll explore these fascinating branches and uncover the rules that govern our universe. In the next part, we'll dive into the laws of motion, Newton's groundbreaking contribution to science. Stay tuned. Newton's laws of motion are the cornerstone of classical mechanics, providing a framework to understand how objects move. These laws govern the motion of everything around us, from falling apples to orbiting planets. Let's break them down. The first law, also called the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Imagine a book resting on a table. It will stay there unless you push it. Similarly, a ball rolling on a smooth surface will keep rolling until friction or another force stops it. The second law explains how force, mass, and acceleration are connected. It's summarized by the equation F equals ma, where F is force, m is mass, and a is acceleration. This means the heavier an object, the more force is required to move it. For example, pushing an empty cart is easier than pushing one filled with groceries. The third law is perhaps the most famous. For every action, there is an equal and opposite reaction. When you jump off a boat, the boat moves backward as your body moves forward. Rockets use this principle by expelling gas downward, which propels them upward. These laws form the foundation for understanding the behavior of objects in motion and are crucial for fields like engineering, transportation, and even sports science. Beyond Newton's laws, energy plays a key role in physics. Kinetic energy is the energy of motion, while potential energy is stored energy. For example, a pendulum swinging has maximum kinetic energy at the lowest point of its swing and maximum potential energy at its highest point. The concept of work and power ties into energy. Work is done when a force moves an object, while power measures how quickly that work is done. Lifting a heavy box takes more work than lifting a light one, and doing it faster requires more power. In the next part, we'll explore the fascinating world of thermodynamics, where we'll see how heat and energy interact in nature. Thermodynamics is the branch of physics that studies the relationship between heat, energy, and work. It plays a vital role in understanding natural processes and how energy flows in the universe. Let's start by exploring its basic principles. The first law of thermodynamics is often called the law of energy conservation. It states that energy cannot be created or destroyed, only transferred or transformed. For example, when you boil water, the heat energy from the stove transfers to the water, turning it into steam. The energy isn't lost, it changes form. The second law introduces the concept of entropy, which measures the disorder in a system. It tells us that energy naturally flows from a high energy state to a low energy state, like heat flowing from a hot cup of coffee to the cooler surrounding air. This is why perpetual motion machines, which claim to run forever without losing energy, are impossible. The third law states that as the temperature of a system approaches absolute zero, the entropy or disorder of the system approaches a constant minimum. Absolute zero is the coldest possible temperature, where particles theoretically stop moving entirely. Thermodynamics isn't just theoretical, it's all around us. Engines, refrigerators, and power plants rely on thermodynamic principles to function. For example, in a car engine, fuel burns to create heat energy, which is then converted into mechanical work that moves the car. Another fascinating application is in the study of heat transfer, which occurs through conduction, convection, and radiation. Conduction happens when heat transfers through a solid object, like a metal spoon getting hot in a cup of tea. Convection occurs in fluids, such as warm air rising and cool air sinking. Radiation is heat transfer through electromagnetic waves, like the warmth you feel from the sun. Thermodynamics is essential for understanding energy efficiency, climate science, and even the future of renewable energy. In the next part, we'll dive into electromagnetism, exploring how electric and magnetic fields shape our modern world. Electromagnetism is the branch of physics that studies the interaction between electricity and magnetism. It is one of the four fundamental forces of nature and plays a key role in shaping modern technology. Electricity begins with electric charges, which can either be positive or negative. Opposite charges attract, while like charges repel. These charges create electric fields, invisible forces that influence other charges nearby. When charges move, they create an electric current, which powers everything from light bulbs to smartphones. Magnetism is closely connected to electricity. Moving electric charges generate magnetic fields, and these fields can influence the motion of other charges. This relationship is the foundation of electromagnetism and was first discovered by scientists like Michael Faraday and James Clerk Maxwell. A simple example of this connection is an electromagnet. By running an electric current through a coiled wire, you can create a magnetic field strong enough to lift objects. Electromagnets are used in motors, speakers, and even MRI machines. Electromagnetic waves are another important aspect of this field. They are created when electric and magnetic fields interact and propagate through space. These waves include visible light, radio waves, X-rays, and more. Without them, we wouldn't have wireless communication, GPS, or even basic vision. The study of electromagnetism has led to countless innovations, from electric power generation to advanced communication systems. Think about how electricity flows through power lines, how magnets store data in hard drives, or how electromagnetic waves transmit signals for your favorite TV shows. Physics is a journey of discovery, from the forces that govern motion to the energy driving the universe. Understanding electromagnetism reveals how deeply interconnected our world is and inspires us to push the boundaries of what's possible. This concludes our exploration of general physics. Whether it's Newton's laws, thermodynamics, or electromagnetism, each concept helps us unlock the mysteries of the universe. Keep learning, keep exploring, and let the power of physics guide you to new horizons.